Welcome back. Welcome back to Learning with me, Ms. Killen, here at MPB. We are still in Unit 11, our statistics with two variables. Today we're looking at our Lesson 4. We are putting a line of best fit to scatter plots. I can classify and interpret line of best fit for a data set when graphed in a scatter plot. So let's go back from a previous lesson to that sleep versus our scores. So we want to remember what we did, how we put that in our calculator or our Desmos, how we looked at all of that information about finding the scatter plot, how we saw how we could find the information for our different formulas depending on which one it was. So obviously we're still with our different students, their hours of sleep, and their scores. Now it says, when data is collected and displayed on a scatter plot, it's often helpful to represent the data with a linear equation to predict unknowns that are not in the data set. So we are really looking at finding that information from these scatter plots that we've graphed. So that's what we're doing. So obviously here is a scatter plot of our data. And when we drew that line of best fit, we also see it called a trend line. A trend line or a line of best fit is a straight line that best represents the data on the plot. This line may pass through some, all, or none of the data. It's around the best fit. It's a trend of what it could be. All right, so it says, let's see how to use and work with these trend lines. So the first thing we want to do to create these trend lines, we want to create our scatter plot. You can do that pencil paper, calculator, you can do that on Desmos. Just create the scatter plot. The next thing we want to do, if you do not have the Desmos or the calculator at hand, you can find a line by using just the data that you are graphing. You want to choose a line where the points are as close as possible. Next, to find your slope, you're going to use 2 points that fall closest to your line. You want to solve for your slope, which is rise over run. You're going to estimate the y-intercept. Sometimes it'll be extremely easy to find that y-intercept, sometimes it won't. And then the last, you want to estimate if you cannot find exactly what it is. So you're either trying to figure out what it is or you're estimating. So that's why I have it up here twice, because it's very important that you either use the technology or you about find it or you exactly find it. So you may have to estimate some. This equation can be used to find unknown data not in the set. So let's follow the following example to write an equation for our trend line. Jason, MPB social media analyst, wants to explain the relationship between the number of posts our news influencers make per week and the average number of likes they receive per post. Over 15 weeks, Jason tracks Lauren's, one of our influencers, post behavior and records the number of posts made that week and the average number of likes per post. So we've made a table, posts per week and average likes per post. So we're wanting to make sure that we are understanding how we're reading these tables. So the next thing we want to do is we want to look at this table and let's go ahead and plug it into our Desmos. So I'm going to pull my Desmos up. There we go. And I'm going to plug my table in. So let's go ahead and plug this table in. So I've got 2, 3, 1, 4, 5, 2, 6, 3, 7, 5, 4, 6, 3, 2, 7. All right. So now let's go for our likes. We have 180. We have 210. We have 150. We have 230. We have 260. We have 170, we have 290, 200, 310, 250, 240, 275, 195, 160, and 300. So let's see what Desmos can gather the information for us. So I'm going to go down here and I'm going to plug in my information. So y sub 1, I have to go and grab my squiggle line. Then I'm going to put M x sub 1, and then I'm going to add my B. And it gives me all the information that I'm going to need. Now we want to make sure that we are paying attention to what our M is, what our B is, those parameters. We want to make sure that we're paying close attention to them. We also want to look at that. There is a scatter plot with the line of best fit on there. So you also want to make sure that you're looking at the scatter plot. Now, this line of best fit goes through some points, and then there's some points that it doesn't go through. So we want to make sure that we're looking at this scatter plot. So here we go. So the first thing that I want to answer about this problem, use a scatter plot of the data to calculate the line of best fit. Well, we did that. We have y equals 26.8269 x plus 120.692. So we calculated our scatter plot and we got our equation. Next it says write our equation, and we did. And our last one tells us use the equation to predict how many likes Lauren might get per post if they post 10 times a week. So what I'm doing here is, I'm grabbing another color, I'm going to put 10 in place of my x. Now that is calculator skills. I'm going to put this equation into my calculator. I'm going to put 10 in place of x and press enter and see what you get. Once you do that, you get y equals 388.961. Obviously, I can't have a portion of a post, so we're going to say it's approximately 389 likes. You want to make sure that you're understanding the rules of this rounding. You can't have a portion of something physical. So depending on what your decimal is, you're either going to round up or you're going to stay the same. So obviously, with a 0.9, we rounded up. Good job. A new word about prediction is extrapolation. In mathematics, extrapolation is a type of estimation beyond the original observation range of the value of the variables based on the relationship between one another. So, in our terms, that means this is predicting values that fall outside the range of the given data, either beyond the highest or the lowest points. So, extrapolation is going to be outside of the norm, so to speak. Interpolations is the new word of prediction in mathematical field. Numerical analyst, interpolation is a type of estimation, a method of constructing new data points based on the range of a discrete set of known data. Ms. Killen, what does that mean? Obviously, it's predicting the values that's inside the data that's already given. So it's inside the norm. It's inter. So we can see inside. The extrapolation is the extra or the outside. So that's our two new words of prediction. So let's look at some calculator skills. So what we have here is cage 212 in Tupelo. It has a different type of sandwiches. The data below shows the total fat in grams and total calories of their toppings and their best 6 selling sandwiches. So we have our sandwiches, we have our total fat grams, and we have our total calories. So what we want to do is use our calculator for this. We can find that line of best fit using our calculator, and we can find that line of best fit using our Desmos. Now, this is what we do to plug it into our calculator. We enter the data in list 1 and list 2. Our list 1 is going to be our X values, which is our fat grams, and our list 2 is going to be our Y values, which is our calorie. We're going to prepare our scatter plot. Remember how we go to our stat plot? We're using that first point that looks like this. It literally looks like the scatter plot. Okay, so we're going to have our calculator determine the line of best fit. We're still in our stat, and we're going to the right to our calculator and go down to our linear regression. And then we're going to hit graph. We are going to see that scatter plot and that line of best fit. So now we have our Desmos showing us how we're doing line of best fit with our scatter plot. Now we have exactly how to do our calculator skills to show that scatter plot and that line of best fit. So we've got these two types of technology that's helping us with these. So let's see. Now you use your equation to predict the calories of the peony bread, ham and cheese with 12 grams of fat. So you put this into your calculator and you've got your line of best fits equation, and that would be, let me write it up here. I have y equals 11.707 x plus 80.28. Let's make sure we have that decimal. Now I want to know about 12 grams of fat. So I am going to replace that x with my 12, plug that into my calculator, which is a straight calculator skill, and I'm getting about 220.77. I did put about because I did round. You want to make sure that you're understanding those rounding. Now, we have got the step-by-step of how to plug this in the calculator. So we're putting this table in the calculator. We're going to that regression and getting that line of best fit information. We're putting that into our y equals mx plus b format, and then we are predicting 12 grams of fat would be around 220.77 calories. So we're taking the concept, what we've learned, and we're putting that concept into this context of our problem. That's all this math is about, learning the concept and putting it into the context of the situation. All right, so let's see. Let's do some practice. Remember, always read and annotate your passage. Make sure that you understand what is being asked of you in the problem. Don't rush. That is very important. Ms. Abair, a counselor at Saltillo High School, wants to understand how working part-time affects the students' weekly spending money. She surveys 10 students at lunch, records how many hours each student works per week and how much spending money they typically have at the end of the week. And she made this table. So you want to make sure that you're understanding the table, the hours they worked, the money that they had at the end of the week. So here are your 3 questions. You go ahead and work these. I'm going to give you a minute, and then we're going to come back and work them together. Okay, so we use Desmos, and we put this in our Desmos as our x and y values. We go ahead and we pull up that linear regression, and we get the information of y equals mx plus b. And we know the information that it gives us is y equals 9.253x plus 168. Let me rewrite that so it looks a little better. 1.168. Now, for me to use this y equals mx plus b, I'm wanting to get my numbers a little bit more reasonable. So let's go ahead and round them one more time to get our numbers with 2 decimals. So here we go. So I'm going to use y equals 9.25x plus 1.17, making sure we rounded that 6 to 7 because of the 8. So now that we've written our line of best fit, let's look at number 2. Use the equation to predict how much money a student would have if they worked 14 hours. Now, what am I asking? I am asking for you to take this 14 and plug it in for this x. So simple calculation, 9.25 times 14 plus 1.17, and I get for his money $130.71. Number 3 says, what can be said about the slope? What does the slope mean in this scenario? So when we're looking at this slope right here, it means for every hour that they're working, they're having $9.25 of spending money. So we want to make sure that we're understanding what our slope is talking about in our linear regression. It's not just to have the linear regression. You need to know what that means, what your slope means. 1.17, that is our y-intercept. So you've got to make sure that you're understanding what all the parts of your equation mean. Good job. All right, time for you to master. You and your table partner, I want you to follow the work of the problem, make sure that you're reading the passage correctly. Make sure that you understand what it's asking you to solve. So here we go. This question is from the Mississippi Department of Education, the Algebra 1 practice test. You will see something like this when you take your end of the year test. So here we go. Evan's science class planted sunflower seeds as part of a research project. A student was sent out each week to measure the height of the flower of their choice. The data in the scatter plot shows their findings from week 2 to week 12. So here is their graph that they made, height in inches for their Y, number of weeks for their X. So using this graph, you and your table partner determine which function, h of w, approximates the height of the sunflowers after W weeks. Now, the easiest way to answer this question, to me, plug each one of these in here and pull a scatter plot or pull what your graph would be. So I would put this into y equals, and then I would pull my table. And I would have 2 and 3. I would have 3 and 4. I would have 4 around 10. I would have 5, 12. Which one has a table that represents most of these plots? Absolutely. It would be D. So sometimes some of these questions that we have in our end of the year assessment is just being able to plug it into our calculator or plug it into Desmos and see which one gives us what they gave us as our table. So sometimes it's not necessarily being able to figure out all that math, is to see which one shows us what they've already given us. All right? We want to remember how we use our calculator to make scatter plots. We also want to make sure that we can calculate to find that equation for our trend lines or that line of best fit. And we want to make sure that we can interpret our slope for our scatter plots. We are almost to the end of Unit 11. We are almost to the end of Algebra 1. So stay with me. And as always, this is Ms. Killen. Have a great day.